exponential equation. Solution. We have that 4 raised to power 3x plus 5 divided by 16 raised to power x. This is supposed to give us 64. Okay, so we can write 4 raised to power 3x plus 5 as 2 raised to power 2 multiplying by 3x plus 5 divided by 16 raised to power x can be expressed as 2 raised to power 4 raised to power x. This is equal to 64. Okay, so that now we are going to have 2 raised to power 2 multiplied by 3x plus 5 divided by 2 raised to power 4x. This is equal to 64 can be expressed as 2 raised to power 6. Okay, so this is equal to 2 raised to power 6. Multiply this side by 2 raised to power 4x, and also this side multiplying by 2 raised to power 4x. Okay, so 2 raised to power 4x simplifies, so that now we're going to have 2 raised to power 2 multiplying by 3x plus 5. This is equal to 2 raised to power 6 multiplying by 2 raised to power 4x. Okay, we have 2 raised to power 2 multiplying by 3x plus 5. This is equal to 2 raised to power 6 multiplying by 2 raised to power 4x. Okay, so that now we can apply this identity that a raised to power n multiplying by a raised to power m. This can be expressed as a n plus m. Okay, so that now we're going to have 2 raised to power 2 multiplying by 3x plus 5. This is equal to 2. Now this is 6 plus 4x. Okay, so that since the bases are common, we're going to apply this identity that if you have b raised to power n, this is equal to b raised to power m. Okay, we are saying the bases are common, then the powers, we just consider the powers, so that n is equal to m. So applying this identity, that shows that we're going to have 2 multiplying by 3x. This is equal to 6 plus 4x. We are saying that we are still verifying that 4 raised to power 3 multiplying by the value of x, which is negative 2 plus 5 divided by 16 raised to power negative 2 should give us 64. Okay, now we have that 4, this is 3 times negative 2, which is negative 6 plus 5. Okay, which gives us negative 1. Okay, divided by 16 raised to power negative 2. This is supposed to give us a value of 64. Okay, now since we see that 4 can be expressed as 2 raised to power 2 multiplying by negative 1 divided by 4, and that is 2 raised to power 4 multiplying by negative 2. This can be expressed as 2, okay, raised to power, this is negative 2, this is 2 times negative 1. Remember, if you say a raised to power n multiplying by n, this can be expressed as a n multiplying by m. Okay, so that's why we arrive at 2 raised to power negative 2. Okay, again, this is divided by 2 raised to power negative 8. That is 4 times negative 2, which is negative 8. Okay, now applying the identity that if you have a raised to power n divided by a raised to power m, this can be expressed as a raised to power n minus m. Okay, so let's apply this identity so that we're going to have 2 raised to power negative 2. Okay, the bases are common, so this is minus into the bracket minus 8, so that we're going to have 2 raised to power negative 2 plus 8. Okay, so negative 2 plus 8, this is equal to 2 raised to power 6. Okay, so we have 2 raised to power 6. This is supposed to give us 64. And it's true that if you say 2 raised to power 6, this is equal to 64, which happens to be equal to 64. So that means that the left hand side is equal to the right hand side. Okay, and that affirms that the value of x, which is negative 2. This is the solution to our equation, to our exponential.